Hello viewers, welcome to EF. Today I would like to explain the complexity of Turing machine. This is the ninth video. Before I already explained about what is deterministic Turing machine, what is non-deterministic Turing machine. Please have a look at those videos first. Okay, let's see. What is the complexity of deterministic Turing machine? Let's say we have an input W 00 which has the input size W, that is the length of W is 2. Then let's say after 7th step W is accepted, or maybe the input is 01 where we have input size n, and this input is accepted after 8 steps. In a similar fashion, for 1 we have input size n, means input size is 2 for W input, and for 1 it will take 3 steps to accept the input. Now this is different cases. How do we will determine a situation for the deterministic Turing machine? So for the first case, if a machine M be deterministic Turing machine and W is the input, a particular input which belongs to sigma star, then the computational time of M on W is given by TMW, defined as the supremum of I, such that we give W at the initial state, and after I many steps it will give us alpha for arbitrary configuration alpha. Now if we have n which belongs to natural number, then the computational time of M on inputs of size n is defined by Tm of n is defined by the maximum of Tm x, such that the cardinality of x is equals to n, where x belongs to sigma star, and you can say x is also the element of W. Now if we consider a function where I have input is a natural number and output is a natural number which maps input to output, then my deterministic Turing machine will have the most time complexity of function of n, that is Tm of n is equals to order of big O order of function of n. So what it means? For the first case, when I have Tm of W, in that case W is equals to 0. At that case we will always take the number of steps for the particular input will be the number of steps will be the computational time of a program, and it is the supremum overall I many steps. So that is supremum of I. So now the question is, what is supremum? Supremum means the least. Supremum means the upper bound. That is, supremum means the least upper bound, which means that the smallest value in the upper bound. For more detail, let's say we have a set where we have the values smaller than 2, where I has the value and the value should be bigger than 4. In that case, we have the upper bound is 4 and 2 is our lower bound, and the values will be greater than 4 also. So we can say 4 is the value that is greater than all the values in the set, but smallest value means there is also infinite value greater than 4, or 4 is the supremum value. So supremum of 4 is a one situation. So the computational time and a particular input W input, we have a supremum overall of I many steps, means the supremum of I many steps. Now if we have a situation like T of n, that is we have the length of the computational computation of the specific size of n, that will be the worst case complexity, means we have the maximum of the input size n. So in that situation, which basically means that you take the maximum of overall input with the same size of input n. So the computational time of M deterministic Turing machine on input size n is defined by the maximum of runtime over the input of the given input size. So in our example, it will be of course the 8, because this is the worst case. On W input 0 1 input size n, we have the 8 steps to terminates, or maybe accepting the state. So that is the example of TMF n. And simply we can say, if we have a function, it is just a big O of the function. So now the question comes, what is a big O function? In my next video, I will discuss about different kind of complexity, especially the big O function. So stay with us. Thank you for watching this video. See you again.